Okay, so let's prove the cosine law using vectors properly. So let's create any old triangle. Let's call this ABC. This will be little a, this will be little b, and this will be little c. And what we want to do is we want to show any of these three forms. That would be wonderful. That would be wonderful. And that would be wonderful. We don't need all of them, we just need to prove one of them. So we're going to start off with talking about vector BC. This is vector BC. I could have started off talking about any of the vectors, but BC seems like a nice guy. So we'll start off talking about BC. Now we're going to notice that BC, vector BC, is actually a composite vector. I could make BC out of going from B to A plus A to C. So here's B to A, and here's A to C. So if I go down here, and if I go down here, it's the same as that vector. So this is vector addition. Okay, now what I'm going to do is different now. I'm going to do BC, and I'm going to subtract BA from this side. Well, if I do that, if I subtract BA from this side, I have to subtract BA from this side. And what's going to happen is, if I subtract both sides, these two are going to cancel each other out. So I'm going to end up with BC minus BA equals AC. And that's just simple vector addition and subtraction over an equation. We should be okay with that. Now the next part I'm going to do is what we were doing in class. I'm going to square both sides per se. I'm going to take the dot product of both sides. So I'm going to take the dot product of this side with itself, and I'm going to take the dot product of the other side with itself. I'm going to expand this, so it's going to be BC minus BA dot BC. Subtract BC minus BA dot BA. And the other side's simply going to be AC squared. So what I did was I took this and I distribute it over the subtraction. Now we're going to take this and distribute it this way. What we come up with is BC dot BC minus BA dot BC negative BC dot BA negative negative positive BA dot BA equals magnitude of AC squared. So this will be the magnitude of BC squared. The commutative property of the dot product says that those two things are equal. So I've got two of them. And I've got BA squared AC squared. So this is looking good. I've got my minus and I've got my dot product here. Let's see what this is going to work out to. BC is going to be A. Now this is going to be the magnitude of BA times the magnitude of BC times cosine the angle between BA and BC. Well, BA is here and BC is here. And look at how they're set up. BA is going this way and BC is going this way, which means this angle is angle B. So that's a good thing. BA squared is going to be C squared, and AC squared is B squared. Hey, we've done it. I've got my B here and my B here. Let's just put it in a form that you're going to recognize. We'll write this one first. We'll put the A squared next, plus the C squared next, minus 2 BA is C, BC is A, so I can do BA cos B, or B squared equals A squared plus C squared minus 2AB cos B. And we did it! We did it, ladies and gentlemen. We have proven it. And the secret was being careful when we did this dot product. This dot product gives us the angle between this vector and this vector. In class, we weren't getting at the proper angle. But if I do BA and BC, the angle between them is angle B, and it all works out. And to get that, I had to do some working around to make sure that I started with that. And that took some practice. All right, ladies and gentlemen, there you go.